Okay, good afternoon to all. Already you are knowing me. Myself is Dr. Prakash B Nangare. I am teaching you the subject fluid mechanics, which is new to you as per the new syllabus. And today you have to discuss about the fluid mechanics practical. And this is now the last practical on the minor losses in case of the pipe flow. So the minor losses in pipe flow. Already you had seen the experiment on the major losses through the virtual lab, which was developed by the NIT Surathkal. And today you want to look out the minor losses in the pipe flow. In the pipe flow. So actually, you know the difference in between the pipe flow and the open channel flow. So in case of the pipe flow, you are observing the losses like major loss and the minor loss. So the major loss you have to be observed due to the friction parameter as per the Darcy's Weisbach equation, and which is now equal to FLV square by 2GD is the equation you apply. So this is Darcy's Weisbach equation. By using this equation, you have to find out the major loss. But practically, you have to find out this major loss by using the U-tube differential manometer. So this is the type of manometer. So you're observing this is the section of this pipe where the left limb is connected to the one point along the length of the pipe. Another point is connected on the other point of the pipe flow. And you are observing the pressure difference in between the 2 points for major loss. So you are observing this head loss in terms of the mercury column. So the mercury column, you know, you will be getting this value as x, and x is nothing but this total difference, that is now the x. And you have to find out the head loss due to the friction as per the or according to the fluid, which fluid is also flowing into the pipe. And if water is flowing, then you need to multiply by the specific gravity of this manometric liquid as mercury minus of the 1 into the x value. So therefore the final parameter is 12.6 into the x, and you will be getting the head loss due to the friction by as per the Darcy-Weisbach equation. Now similarly in case of the minor losses, in case of the pipe flow, so actually you are observing the list of minor losses. Just I want to tell you the first name, that is entry loss. Second one is the exit loss. Then you know the gradual enlargement and the contraction, sudden enlargement and the contractions, and due to the connection of the bends or the various fittings, you are observing the loss. I want to tell you the one example. Suppose this is a section of the pipe having the diameter D1, and if you are observing the enlarged section like this, when the diameter is increased, again the section for the pipe you have to be observed like this. So the diameter for this enlarged section as a D1, a D2. Or suppose you want to observe the losses in between the enlargement section and this contracted section. Then same way you have to carry it out. Either this diameter is remains the same or as equal to the D1. Now how you get this pressure difference? So the left limb is also connected to the point of this first pipe, and right limb is also connected to the point with the second sections. And by using the YouTube differential manometer, same way you have to observe the pressure difference. But here in case of the minor losses, you have to call as the HL. Then for diameter D1,
Sir,
the velocity of the flow is V1,
sir,
and
मुलांना ऍडमिट
for
कर.
diameter, okay, for diameter D2, the velocity of the flow as a V2. Then see this head loss due to the various connections, and the minor losses is going to be observed if the length of the pipe is too large. Then you have to neglect the minor losses. In case of water distribution system or in case of the sewerage distribution system, you could not be consider the minor losses while you design it. But you must be learn it what are the least of the minor losses. Already you studied this chapter in theory, and you're observing that it's how to find out this hydraulic loss due to this various fittings or this enlargement section or the gradual change or gradual contraction. So this for only for the entry and the exit loss you have to utilize kv square by 2g, kv square by 2g. K is the constant, and this constant you can be find out if you are knowing the velocity and the HL with the help of YouTube differential manometer. You will be getting the value of the K, and the range of this K value from this 0.5 to 1.0 up to 1.2. For example, this is the entry loss. Entry loss, how I should get it? The velocity for the first entry, add the entry as a V1. So I take here the V1, so the K V1 square by 2G. Suppose at the exit, the velocity of the flow as a V3, if the diameter change. Then I could write here the V3 square by 2G is the minor loss due to the exit now. Then you have to observe for this sudden contraction or gradual contraction and the enlargement section. Formula is remain the same. Suppose V1 is the velocity, V2 is the velocity for the enlarged section. Therefore, this HL is equal to K into V1 minus V2 square by 2G. So this is the formula you have to utilize to find out the minor losses. Now in this experimental setup, directly you are getting the pressure difference as a part of hydraulic loss with the help of YouTube differential manometer. Then you can be worked out this K value. So this is the way to find out the minor losses. So according to that, we'll see the actual experimental setup on a YouTube channel. I am taking this is the link. I will go with that link, and you have to be observed those links on a YouTube channel.
This is experiment for minor losses in pipe fittings. Here they have to note down the minor loss for the sudden contraction, sudden expansion, and sudden 90-degree bend. These three experiment we have to note down the reading. For the sudden expansion, sudden contraction, you have 3 reading. Sudden expansion, you have to take 3 reading, and sudden bend for 90 degree, you have to take the 3 reading. There is only one butterfly valve This is along the pipe, it is means it is open. If you close this, it is perpendicular to the pipe means it is closed. You have to keep the in open condition before you start the experiment. And this is the gate wall, this has to be in open condition. And note down the manometer initial reading, mercury level, this has to be 0. Then this valve should be closed initially, and butterfly valve of collecting tank should be open. First you have to start the machine by pressing here. The water will start flow from pipe, from the pump. From the pump it will flow through this pipe. Now we are doing for the sudden contraction. Therefore, these two valves should be open. You will get the difference at this point and this point. This will get the difference here. In the manometer, we will get the difference. So we have to open the manometer valve in order to release the air bubble. Then wait for some minutes in order to release the air bubble. Then close the manometer valve. You will get the difference H1 and H2. Take these two readings. Then take the collecting tank reading by closing the butterfly valve of collecting tank. Wait for some minutes. Okay. At 10, you have to start the stopwatch. Wait for to reach it is 20 means 10 centimeter of increment. What time will be taken for increment of 10 centimeter water level rise? That is the time taken for your value. Stop the watch. Take the time taken for 10 centimeter of increment of water level. This is the first reading. For the second reading, change the flow by rotating the gate valve clockwise. Rotate it, the flow will decrease. Okay, now flow is decreased. Now again you will get the different value for manometer. Take down the reading here. Again same procedure. You have to open the butterfly valve and again you have to take the reading for 10 centimeter of increment of water. Okay. Start the stopwatch at any point and now stop the stopwatch. Note down the reading. Take time taken for 10 centimeter of increment of water level. This is the second reading. For the third reading, we have to give some rotation. Again, we will get the difference. Same procedure we have to continue this to this reading also. You have to close the butterfly valve and take the 10 centimeter of water level instrument. This is for sudden contraction. Sudden contraction. You have to do for the sudden expansion. Same procedure you have to do for the sudden expansion and sudden bend. You have to close the